Hi, my name is Elena and I was born on January 8th, just like Stephen Hawking, David Bowie, Elvis Presley, and of course myself.
But of the 32 million people born on January 8th since 1930, I've never met anybody born on my birthday.
Why is that?
Well, in 1939, this guy named Richard von Mises created a problem called the birthday problem, better known today as the birthday paradox. Oh, sorry, not the birthday paradox, the birthday paradox. But beware, because we're about to get into some pretty confusing stuff. So the birthday paradox goes like this. Pretend you have invited 23 people to your birthday party, including yourself. Surprisingly, the odds of 2 people at your birthday party having the same birthday are 50-50. Let's just hope they don't have the same birthday as you. So how does this work and why is it true? Well, the odds of 2 people meeting having the same birthday of a group of 75 people is almost 100%. Wait, I'm sorry. Let's just slow down a bit. I know this is confusing, which is precisely why it's called a paradox. So put your thinking caps on. Let's break this down. So in a room of 23 people, there is a much greater chance of meeting someone born on your birthday. There are a certain number of comparisons you can make with certain people. So the first person has 22 comparisons to make, but the second person has already compared to the first person, so there are only 21 comparisons to make. The third person has 20 comparisons, the fourth has 19, the fifth is 18, and so on.
Wow, that was a mouthful, but here are some of the equations you can use to solve the number of combinations. The easiest way of solving this problem is to find the odds of not meeting a person born on your birthday. So that's 364 divided by 365, and then you would raise that to the 253rd power. So why do we raise it to the 253rd power? Well, probability is exponential, so think about it with flipping a coin and getting heads. Well, flip it once, the odds of getting heads is 50%. Twice, 25%, 3 times, 12.5%. But it's not 0.5 divided by 1, 0.5 divided by 2, or 0.5 divided by 3. Like I said, it's exponential. Instead, you're going to raise the odds to however many times you flip it. So the odds are 50%, and if you flip it 2 times, it's 0.5 to the second power. And that's the case for the birthday. So you raise it to the 253rd power because that's how many times you meet someone with or without your birthday.
Now that we know this, we know that as a group gets bigger, the odds of not meeting someone with your birthday exponentially decrease.
Doing this simple math, we know that we can just subtract the odds of not meeting someone with your birthday from 100%, and then you know the odds of actually meeting someone with your birthday in a group of 23 people.
Pretty cool, right? But you probably think this is kind of pointless, but trust me, it's not. It shows how probability is exponential, and it shows how hard it is for the human mind to wrap their head around such high exponents. But most importantly, this probability problem has helped with many real-life scenarios. And plus, it's just totally awesome. And I guess I'll just leave you with the generalized formula. And if you don't believe me, go into a room with 75 people, or try with any number, and I bet you $250,000 that 2 of them will have the same birthday.